Hello, everyone. I'm Jim Garrison, and I want to welcome you to day 95 of Humanity Rising. Virtually every day at 5 o'clock p.m. Central European Time, Ubiquity University, and as of today, 312 official partnering organizations have come together to provide an open space so that people from around the world can share their experiences as we all navigate through this extraordinary pandemic, which has put all of us into some form of lockdown, some form of social distancing, an acute awareness of our health, and anxiety about the human future. The whole world is in the same conversation. And so Humanity Rising has been convened with the purpose of both allowing us to share our experiences and to come together to take counsel as to how we can more effectively enhance our strategic effectiveness. And over the 95 days, we've heard from people literally all over the world across a range of issues. And we, 7 months in, are coming to an awareness that the pandemic is far from over. And we have to take that in individually, as families, as communities, as the world, that COVID-19 is going to be with us for some time. And so it's fundamental that we understand the root cause for the pandemic. And that's climate change. I was very heartened today to hear the governor of California and the governor of Washington State yesterday state unequivocally and as governors in an official capacity that the fires that are raging along the entire western coast of the United States are due to climate change. This is rather new in the US, and it's not very often even worldwide. Governments have, for the most part, refused to acknowledge the fundamental role of climate change in both extreme weather events and in the spawning of infectious disease and pandemics. But that's the reality. So every so often on our Humanity Rising programs, we've dealt with climate change. It's probably the world's most critical issue, bar none. And unless and until we solve this problem, all of our crises are going to continue to be exacerbated and spin out of control, as the fires are doing right now, as the pandemic is doing right now, and a range of other global issues. So today we're delighted to focus exclusively on the issue of global warming. And we're honored to have a couple of engineers and scientists with us who will be exploring this theme. And so I want to now turn it over to Sabine van Gafka, my good friend and co-moderator, who will initiate the program. Sabine?
Thank you very much, Jim, and a warm welcome to all of our viewers around the world, and also our participants in the chat and the Zoom call, who always give us such great feedback and have a great dialogue. And like Jim said, today is a really important session, because climate change is the absolute core of how we are going to change the world, but also what needs to be done. And that we need to diminish or stop the use of fossil fuels to stop the escalation of climate change, and instead focus on sustainable alternatives, clean, green energy, whether it's solar, wind, hydroelectric energy, and so forth, is of course essential. It's something we all know, but I do also agree with you that that it's also coming from a government level where they actually address it, that the catastrophes that are going around when it comes to weather and all the other issues that we're currently seeing in addition to COVID is really a result of climate change. And having from time to time, I look at the Keeling curve, which is provided by the Scripps Institution of Oceanography. That was a difficult, all of a sudden, tongue twister. But anyway, they daily and weekly and monthly give readings of atmospheric carbon dioxide. And I also read that the CO2 concentrations over the past 800,000 years reveal just how much human activity has impacted the world compared to pre-industrial times. And I mean, if we think about it, agriculture began 12,000 years ago, and the human civilization, let's say, is considered to be around roughly 6,000 years old. And in all of that time, carbon dioxide levels are said to have been between, if I read correctly, 260 and 280 ppm. And in just 150 years, and that's not really a long time, we've nearly added 50% on top of what was already naturally here. And of course, this is also showing now these profound effects on our climate and on our environment. And that we have to take steps now, both in our individual lives, on a societal scale, and on a nation scale is totally and irreversible. Yes, we have to. And it is about also bringing solutions to the world, because a lot in media we're portraying the problems, which of course is important, but it is as important to highlight and give focus to the solutions that are actually here. And there's a vast amount of solutions, innovations across the world who really do have ready solutions to address these problems. And that's why I also find it's such a great platform for Humanity Rising to give people like the engineers we're going to meet today a platform to also convey the solutions that exist. And of course, being a Swede, I'm proud of our teenage environmentalist and climate change activist Greta Thunberg, who really showed the capacity of one person being able to really make change collectively and unify people around a common cause and narrative, and also demanding action. And like Jim said, today is an important session, and I want to give one of our engineers who are joining us, who will be convening this, a short introduction, because he's done a lot of marvelous things. And he's here to tell us about alternatives that he has on stopping global warming. And his name is Tom Hopkins, and he has a solution that is also about extracting heat from our oceans. And Tom has a long career focused on creative engineering. Already in the 1960s, he designed Australia's most daring building. And then in the 1990s, he designed an underwater treadmill on which Olympic gold medalists trained. And then in 2010, he developed the world's most efficient electric motor. And now he's designing the ocean heat pump to extract heat, clean energy, to replace fossil fuels. So he definitely has a lot of knowledge and insight to convey to us. So before I hand over the space to Tom, I want to do something that we now have as a tradition here at Humanity Rising, and that is to just allow us all, or invite us all, to a 1-minute heart coherence meditation. And this is really just to align us to the here and now, connecting to our heart, connecting to all of the energies that are in this space at this moment, and setting an intention of what we actually want to take with us from the session today. So with a beautiful chant in the background of Om Mani Padme Hum, let's take 1 minute and around 6-7 breaths in a heart coherence meditation. And if you like, you can place your hand on your heart. And let's allow ourselves to feel gratitude, to be able arising today. Thank you so much for that. And with that, I would like to hand over the space to Tom Hopkins.
Hello, I'm Tom Hopkins. That was a generous introduction that you gave me, Sabine. I started off as an engineer in Australia, designing high-rise buildings. You mentioned the Daring building. That was actually two buildings, one on top of another in downtown Sydney. And what was daring about it is that we built the top building first in place before the bottom building underneath it. The top building was 25 stories and the bottom building was 30 stories. No skyhooks were allowed. So that's why it was called that. For 10 years, I've been running an engineering company called Zero E Technologies. The E stands for emissions. We're into clean energy. And what we produced first in the last 10 years was this very efficient electric motor. And the idea is that the cleanest energy is the energy we don't use. By having very efficient things, we minimize the use of energy, and you can close power plants, coal burning power plants, etc. So that was our first contribution. And recently, we've started developing the ocean heat pump. I would now like to introduce to you my partner in this enterprise, Bob Redwine. I can't see Bob on the line.
I'm here, Tom. Hello, everyone.
Can people see you?
I don't think so. I can start my video here.
Yeah. Good. So Bob's a professional engineer too, and I asked him to join us because Bob is very active in the carbon arena. Could you tell us about what you do, Bob?
Sure. I'm a structural engineer, have practiced in commercial buildings, residential buildings for the past 40 some odd years. And most recently, I've been focusing a lot on climate change and what the buildings contribute in equivalent CO2 emissions. And I'm totally focused now on finding ways and encouraging others to reduce the amount of CO2 equivalents that buildings produce. So that's been my focus.
Good, thank you. So where engineers fit in the big process is that we don't actually do the science. What we do is we execute on the science. Once the science has a solution, if there's a physical thing required, we step in and do the physical execution of what will solve the problem. You probably actually know very well, familiar with all the things that we do. If you drive on a road, that's engineers do that, bridges, buildings, water systems, build dams, electric power plants. The entire built world usually has engineers and professional engineers involved in doing that. I remember when I first became a chartered professional engineer, my uncle, who was a well-known engineer in Australia, he said, you know, our world is pretty brutal. The gravity doesn't give a damn about us. Gravity just keeps pulling and pulling and pulling. And if we don't get it right, our buildings and our bridges will fall down. So we have a harsh taskmaster, and we can't make mistakes because it's catastrophe if we do. And just as gravity keeps pulling things, carbon dioxide in the air, there's now 1 trillion tons of it, is causing global warming. And so we've been focusing on the global warming for the last 10 years. So at this point, I'd like to start the slideshow and share my screen with you. It says I can't start the screen while the other participant is sharing.
Try it again, Tom.
Okay, it looks like it's going to work. Okay, I have to get back. I have to move all the people watching there. Okay. So my first slide is that in pre-industrial times, people and beasts did all the work. And energy consumption back in 1750, 1800 was 1.2 kilowatt hours per day per person. Today, most of the work is done by fossil fuel powered machines, and our energy consumption has gone up nearly 50-fold, so that we now, between us, use 57 kilowatt hours per day per person. So since 1750, mankind has used 6.5 million terawatt hours of energy from burning fossil fuels. And as a direct result of doing this, we have released 1 trillion tons of CO2 into the atmosphere. And this has caused the world to heat up by 1 million terawatt hours, which equals to a 1 centigrade temperature rise. So the whole...
You might explain what a terawatt hour of energy is to the people.
Well, a terawatt hour, if you use a hairdryer for an hour, it's usually a kilowatt. That's 1 kilowatt hour. A terawatt hour is 1 trillion of those. So imagine 1 trillion people using a hairdryer for an hour, and that's a terawatt. No, I overstated it. It's 1 billion people using 1 kilowatt hour, and that comes to a trillion terawatt hours. So it's an enormous number, amount of energy that's involved. So the fundamental equation that we have, that we all face, is that the energy that comes in from the sun to Earth minus the energy that the Earth radiates out into deep space. If there's a difference, if the sun energy coming in is greater, we have global warming. And we've had global warming pretty actively recently, and that's because we're getting more energy from the sun than the energy that is radiating into space. And what is causing that is the carbon dioxide in the atmosphere that's stopping the energy from escaping. And so to stop global warming, we either have to reduce the amount of energy coming in or increase the amount of energy going out. Now, we work with all these models, and I've prepared a model, and we're going to load it up and release it later today, and you'll be able to click on that link and download the model and do some interesting work. We think we make good predictions up to the year 2030, but I think we underestimate global warming beyond that to the year 2100, because we're not taking into account any change in the ocean's ability to absorb carbon dioxide. And that's what happens to the carbon dioxide. It's gradually absorbed, but if the ocean gets warmer, which it is, it can't absorb as much. We're not taking into account melting of the permafrost and producing lots of methane into the atmosphere. And we're not, yes.
Excuse me. I just wanted to state that I have always looked at this problem from the perspective of IPCC, UNF, CCC, and this perspective that Tom brings is totally different, but the results, the conclusions, the concerns are essentially the same. So I just wanted to mention that.
Thank you. But if anything, we underestimate the impact of what's going to happen in the long haul, because we're assuming rather constant conditions. So what we did to start off is, with our model, we said, let's assume that we do nothing dramatic in the near term. And we used McKinsey consultants. They did a projection 2 years ago, estimating the total energy usage worldwide. And they didn't assume anything dramatic. They just assumed that we were going to be good citizens and carefully with our energy use and bringing in improvements incrementally and slowly. And they produced this projection of all the energy and how much was going to be clean energy. And we took that and we plotted it. And we plotted what happens to the parts per million of CO2 in the atmosphere is that plot on the left-hand side. And right now we're at about 415. And by 2050, we'll be at 496. And by the end of the century, we'll be at 640. And what that means in terms of temperature, we're just above a 1 degree increase now in 2020. By 2050, we'll be at 2.1 centigrade increase. And we will then go on 2010 to be 4.9. So we're currently experiencing extreme weather situations, and it's caused by all this extra energy. Engineers work in numbers of energy. And yes.
Sorry for the interruption. I have another question, or actually an observation. It's been shown that by the IPCC that if emissions of CO2 were stopped immediately, this was as of 2017, that we would reach 1.5 degrees centigrade by 2040. So just a little fact there.
Yeah, well, we're going to be discussing that in a little while, because we modeled that very situation. So unless we do something dramatic, we're in for a very bad time. Now this is I remember I was canoeing with my family in the Colorado River, and this stream, this creek behind me, that's a tributary of the Colorado River. And we were camping for the night, and a great big coal train came by. And the question was, what happens to all that coal? Where's it going? Where's that power station? But the real answer as to where all the coal is going is that it's all going into the atmosphere. It's going to be burnt and then it'll rise up, and that's the source of the trillion tons of CO2 in the atmosphere. The trillion tree program that's been discussed in Humanity Rising can absorb about 5 billion tons of CO2 per year. And that equals about 2.5 Amazon forests. We'd need 15 new Amazon forests to counter the 33 billion tons of CO2 that we are sending up into the atmosphere each year. And that wouldn't be reducing the 1 trillion tons that is already there. So we need big scale things to do it. Now, there are multiple techniques that have been developed to remove carbon dioxide, but
Tom?
it's slow. Yes.
Tom, excuse me again. Another perspective fact is that there are approximately 3 trillion trees on the planet right now. And going back to pre-industrial times of 1850, there were about 4.5 trillion trees. So.
Yeah. And the Amazon has 400 billion trees. So you can see that growing forests, okay, if we had the land available, we have a long, long way to go beyond that. And so we're pretty well out of time, 10 years until there's some major tipping points. And so we urgently need another approach. And the Paris Agreement in 2015, at the time they were meeting, the global temperatures had already risen one degree C, resulting in all of these weather catastrophes that we've been seeing. And the must-do that came out of the Paris Agreement was to hold global temperature rise through to the end of the century to 2 degrees. But that would be pretty disastrous. And so the hope and the big goal is to hold the temperature rise to 1.5, 1.5 degrees centigrade through to the end of the century. And one of the questions Bob raised is that, you know, would banning the use of fossil fuels by 2050 limit the temperature rise to 1.5 C? The EU has committed to achieve zero emissions by 2050, no burning fossil fuels. Presidential candidate Biden, Joe Biden, he proposes to reach, he proposes a similar goal. Of course, we're all aware that President Trump and the Republican Party are global warming deniers, and they're not particularly interested in this whole situation. So to ban all of the fossil fuels, we currently get 145,000 terawatt hours per year from burning fossil fuels like coal, oil, gas, and also biofuels. And right now, clean energy, which is non-emitting, we now use only 16,500 terawatts hours per year that comes from nuclear, hydro, wind, and solar. The picture there shows the East Anglia 1 offshore wind farm. It's just opened. It had a capital cost of 3.1 billion, and assuming a 35% utilization, it would cost $200 trillion to build enough of these conventional wind turbines to take the place of the 145,000 terawatt hours that we are currently getting from burning fossil fuels. So you see, it's an enormous situation. The idea that we're going to quickly replace fossil fuels with clean energy in 30 years, we're talking about extraordinary capital investments to achieve that. Now, my group, we have developed a concept. I woke up in the middle of the night some years ago, and I said, my God, heat is the problem, but the heat is a phenomenal energy source. The heat could be the energy, the clean energy that we need. And so we came up with this concept of a ocean heat pump that goes to where the wind are greatest. And what we do is we pump heat out of the ocean and we store it in big containers of salt. It melts the salt and that's how we store it. And an ocean heat pump generates twice as much electricity per year as a conventional wind turbine. And the reason is that we can operate in very, very heavy winds, whereas a conventional turbine has to sort of shut down, start feathering at 33 miles an hour. We can operate in 100-mile-an-hour winds, which are 27 times more energetic. So we take in a lot more energy, and then something very interesting happens. When you when you extract heat from the sea, for every 1 kilowatt hour of electricity you use, you actually get 3 kilowatt hours of heat. And you store it by melting salt. And if you keep the heat and use the heat as heat for warming buildings, for cooling buildings, for warming water, for desalination, you capture that advantage. But if you take the heat and convert it back to electricity, you end up with slightly less than the 1 kilowatt hour that you used in the first place. So that's the concept we've been developing. And this gives you a look at some of the engineering details. So the big vertical part is a series of wind turbines offset with wing sails that go the opposite way. And you see underneath, you see the big heat exchangers. And we have been working on this for a while. And Mubadala, which is the United Arab Emirates financial arm, said that they would finance the search for some new graphene composites for heat exchangers, which they did. And it was done at the Graphene Engineering Institute in Manchester. And we already have this fabulous material that's far more heat conductive than typical materials that goes under the heat exchanger. We're making progress with this. The National Science Foundation has invited us to come in and request a grant, okay, to do some of the basic works. So that's the concept that we're using.
Tom?
Yes.
Hey, Tom, got another question for you. How many of these machines would be required to generate the 145,000 terawatt hours that you mentioned on a previous slide?
Well, it depends how much energy you're getting from the machine. We studied 50 different cities around the world, and they averaged per year 0.2 terawatt hours. And they were just a random collection. If you only concentrate on the very, very energetic winds, like near the Antarctic and near the Arctic, you get up to 0.4 terawatt hours per year. And so if you focused on the 0.4 terawatt hours per year, and you're trying to do 145,000 terawatts, you can see you're going to need a lot of machines in order to do this. Replacing that much energy just is an enormous, enormous thing. It's not easily and glibly done, which people don't seem to realize, okay, that replacing fossil fuels in 30 years is an extraordinarily difficult situation. So what we did is we used our model and we asked ourselves, we identified the problems. The first one is that it will cost somewhere between $100 trillion and $200 trillion to replace all of the dirty energy with clean energy. The second problem that we don't talk much about here is that the petrostates, like Russia, like the Middle East, like the United States, are very likely to object strenuously to giving up selling oil and gas, and the oil and gas companies will fight the ban. So anyway, we went ahead and we plotted what would happen if we managed to get rid of all the fossil fuels in 30 years and replace them with clean energy, like from wind turbines or nuclear or something like that. And what happens, the graph on the left, we're at 415 parts per million right now in 2020. So we ban the use of fossil fuels and replace with clean energy. And what it means is we reach a peak and we come down, back down a little bit to 432 in 2050. And we continue steadily down to 365 parts per million in 2100. Just stopping the ongoing emissions doesn't solve the problem. The problem is all of the carbon dioxide in the atmosphere already, and it dissipates very slowly. It's absorbed about 1/3 of 1% is absorbed each year into the oceans. So what we emit now will stay in the atmosphere for 880 years before 95% of it is dissipated. And what we're suffering now is from carbon dioxide. Some of it was actually burned in 1750, 1800. It lives that long. Right from the beginning, that carbon dioxide, the beginning of the Industrial Revolution, that carbon dioxide is still in the atmosphere in large quantities.
Hey, Tom. Another comment from an IPCC perspective is that they ran this as well and found that with additional measures, which I think you're going to get to later, this was a 2-degree centigrade pathway. But as Tom pointed out earlier, how difficult it is to replace all fossil fuel generated energy and reduce the anthropogenic CO2 emissions is an enormous task.
Yes, well, so what happens here, you can see that we projected that the temperature by the end of the century would rise to 2.9 degrees, which is above their must not go 2 degrees and a lot higher than their desired 1.5 degrees. So just banning fossil fuels is not going to do it for us. So as Bob just mentioned, we looked at the possibility of augmenting it with other strategies. The one that I like very much is the first one. We can improve our motor and equipment efficiency by 10%. Not using energy is the fastest and the best way to go. And of course, I've got this very highly efficient electric motor. And so we are particularly keen on this first thing. Planting 1 trillion trees, that will remove 5 billion tons of CO2 per year, equal to 2.5 Amazon forests. We also remove CO2 by other means in the model, 5 billion tons per year by various measures, including changing the land use to do it. And so what we found that there was a slight improvement. The parts per million in the atmosphere fell a bit faster, and we reached a maximum of 2.4, and by the end of the century it would start to fall and we'd be down to 2.3 degrees. So banning all of the fossil fuels and augmenting it with all of our good strategies, the little ones that we're using, is really not going to do it for us. So at that point, I started looking for geoengineering techniques that could augment the banning of the fossil fuels and all of the other good things that we're doing. And geoengineering is something that is sort of a stopgap temporary measure to reflect the sun or to block the sun. And there are various, it's our fallback. And if we could reduce the amount of sun coming in by 0.37%, we could stop the global warming. And if we could reflect or stop 0.7% of the sun, we would actually return to pre-industrial conditions in about 100 years. So I went and I looked carefully at the two biggest ones. The first one is stratospheric sulfur injection. I met with NCAR. I met with the top scientist involved with this, and she really helped me understand the program and introduced me to the person that was trying to come up with a physical solution that followed her papers to do it. And the concept is this: it's been noted through the years that whenever there's a volcano, all this stuff is thrown up into the atmosphere and the world gets cooler, you know, noticeably cooler for a year and a half or so. And the idea was to duplicate that. And they came up with a concept to have high flying airplanes like U-2s, but carrying a lot of weight, to dump 8 million tons of sulfates per year at 65,000 feet. I was introduced to the person that did all the calculations. And just like a typical engineer, I said, I want you to send me your calculations so I can review them. He was a bit shocked. I went through them and concluded that his calculations had way underestimated what was needed. But there's all sorts of side effects that this approach has. It can cause acid rain and things like that. But it's the best that we have, but at this stage, it's not very well developed and not very good. The second one that I looked into is a thing called marine cloud brightening. And I was also introduced to the engineer that put together a concept. And he was going to have these boats whizzing about, blasting up salt water spray into stratus clouds, and they would become more reflective. But he needed massive amount. He had to reach 25 million square miles of clouds, and he had to reach it every 2 days. And he had these boats zipping about the oceans, blasting up into the atmosphere when there were stratus clouds. And studies showed that peculiar things would happen. You do it off the coast of Africa, and what happens is the weather changes in the Amazon. It had these cross effects. And nowadays, this is not considered a very likely approach. They all have side effects and disadvantages. And the uncomfortable thing is that right now, there's no fallback plan for us to do what we can do in the event that these other measures work. So my team had a go at coming up with a concept that was simple, and that was, we came up with the idea that we would make big floating ocean mirror, floating mirror fields. And these are made of space frames. And we have ribbon mirrors made out of woven graphene cloth, so they're very, very strong, with silvering on them. And they'll reflect over 95% of the sunshine that's coming in. And we figured out, so we used a stretcher frame to do these floating mirrors. And the reason we wanted to have them ribbons is because when there's a big storm that comes, the mirrors can be wound up, and also they can be cleaned for salt, etc. So these floating mirror fields, they chase the sun. They move north in the northern hemisphere summer, and they move south. They move about 10 miles per day on average. And they stand on legs on pontoons, and they're propelled in the usual fashion with propellers. And because they're high up, they're about 130 feet high, they're 60 feet above the water. The marine life wouldn't notice it. They can swim straight through and be unaware that they're underneath something like a floating mirror field. And we went through all the things that could go wrong, and it looked like that this had serious potential, and we're looking for the opportunity to develop a bit further. But the structure is the same as what we're developing for the ocean heat pump, which are these space frames made out of a special version of polymers. So we started playing around with these mirror fields. Yes.
Hey, Tom. I think there are a couple of questions floating out there that show a good curiosity level about the reflection of the sun, the heat from the sun. So you might explain what that does when it tries to leave the atmosphere versus what the sun does as it enters the atmosphere?
Yes, there are certain wavelengths of sunshine that as they come into the atmosphere, they're absorbed. And so what actually reaches us down here at land level or at sea level is only about 53% of the energy. Nearly half of it has been absorbed already in the atmosphere. And so we then reflect that sunshine, but it's already missing the wavelengths that are absorbed. And so 100% of what we reflect goes out. We don't take the same loss twice. So, but what it means is we have to make the ocean mirror fields twice as big in area as we would have if that phenomenon wasn't there. It's one of these things that we just have to live with, that the physical world has these bloody laws, okay, that we can't violate. We just have to live with them and figure it out. You have another question, Bob? Not at this stage. So I was very heartened with this graph here. What we did is we figured that instead of phasing out the fossil fuels flat out in 30 years, that we give ourselves 100 years to do it. So in the first 30 years, we just phase out 25% of the fossil fuels. We assumed that we'd use all of the augment strategies, the land use and those sorts of things. And we'd install 750,000 square miles of ocean heat pumps, of floating mirror fields. And this is the very fast way, the fastest thing to do would be to start off with the mirror fields, because that can bring us some urgent and quick relief. And the capital cost over 100 years would be 104 trillion. So it's $1 trillion a year for 100 years is what it would cost to do this. And what happens is the parts per million go up to 458 in 2050, and then gradually start to come down to where we are now by the end of the century. But the interesting thing is what happens with the temperatures. And what happens with the temperatures, so we're near the top there where the 1.1 degrees increase in 2020 will go up to 1.3 degrees in 2030. We'll drop to 1 by 2050, and we'll continue on down, and there'll only be a 0.3% temperature increase by the year 2010.
So, just an observation. So this this information is both frightening to me and exciting, actually, because even though 750,000 square miles is a huge number, if you consider some blends of reducing fossil fuel consumption and emissions with this a reduced area of floating mirror fields, you might have a viable solution.
Yes, well, we looked at just using mirror fields and nothing else. And that would do it if we had 1 million square miles. So this, what you're looking at is a blended solution, Bob. It assumes that we ban all fossil fuels, not over 30 years, but over 100 years. The price there is for the 100-year cost of the total thing. You know, when we go through a checklist, you know, of all the things that could go wrong, you know, what's nice about the floating mirror field solution is it's very doable. There's nothing really fancy. There's no planes flying high and dumping pollutants into the atmosphere. It's a sort of, in many ways, a modest approach. And 750,000 square miles, when you consider that we'd operate from 50 south to 50 north, talking about latitude, it is about 0.75% of the sea area would be covered with these floating mirror fields. I mean, that's enormous, but it's not going to block navigation. It's not going to block ships to do. So what I can say is that there is a solution out there that answers a lot of things. And looking at this slide, what we're very concerned about is that the people in developing countries are able to get the energy they need to develop. And this is a meeting of the United Nations Development Program. And they're very keen on sustainable energy is one of the big goals. Interestingly, I wouldn't call heat sustainable. I would call heat unstoppable. It is just coming in at 3.2 million terawatt hours per year, and we're only using 146,000 of it. I mean, it's massive amounts of energy. It's clean, it's quiet, and we'd be in this peculiar situation that the whole paradigm changes. You know, we're all used to living in a situation where energy is scarce. And when I was a kid, my father was always telling me to turn out the lights. You know, we're all the time saving energy and things like that. But if we get to using heat, the more we use, the better. Because if we can pump some heat out of some of the critical environments, reefs, and those sort of marine environments, we help the world. We don't worsen it. So there could be an interesting change in the whole paradigm of scarcity to plenty. And so we came up with an idea, and you can see that we're engineers. You know, we're not really conscious of all the political ins and outs of things. But we thought, you know, what would be a deal that would save planet Earth? And what we suggested is an agreement in effect between all the fossil fuel states, all the fossil fuel companies, other national governments that would agree to, one, the continued use of fossil fuels at 75% of the present usage level until 2040, reducing by another 10% per decade thereafter. And for that, okay, we'll be looking for some way to finance everything, a worldwide carbon tax to fund the development and deployment of the many clean energy systems, the many augmentation systems like growing forests, and also geoengineering programs like stratospheric sulfur injection like the floating mirror fields. So we think that there could be a basis there for a deal. We think that the oil and gas states might well be enthusiastic with the idea that they would be allowed to keep producing oil and gas at a high rate for a long time and only be phased out over 100 years, not 30 years. We think that the developing countries would be very enthusiastic with the idea of having gobs of cheap, clean energy to go forward. And I did a projection that assumed that we would be growing much faster, the world would, as the developing countries come online and start to use more energy than we have now. And it's very positive, and it all fits within the guidelines of not reaching 1.5 degrees C at any point. So that's the concept that we've been working on. I finished. So Bob, do you have any questions that you might ask?
Well, let's see. It's another. I just want to make a comment actually, and that is the fact that the world in general, and specifically a lot of the majority of scientists in the world, have come up with lots of mitigation standards, mitigation pathways. And if you're familiar with the book Drawdown, there are lots of scientists that are focusing on how to actually reduce the CO2 levels in the atmosphere. And what Tom does is sort of grab you by the shoulders and shake you and say, well, what about this? Now, it may not be the correct, perfect answer, but it's the type of thinking that I think we need. We need thinking that's out there, that's a different perspective that says, well, oh yeah, well, maybe. So I would have to really comment that I appreciate that perspective, that sort of outlandish, different way to think about it. I think it's important.
I was thinking how people might react to my presentation, and I was thinking that halfway in they'd be pretty depressed because nothing seemed to work, but that by the end of the presentation they might be a bit happy and excited because there is one path we can see forward, and presumably many other paths that we can see forward. But see, the program, I think that what is needed most urgently is to quickly reflect some of the sunshine. That can be done quickly, much quicker than trying to replace all fossil fuel with clean energy power sources. We can quickly reflect the sunshine, and that would save us. It may even be possible to do it before we get these tipping points that everyone's worried about, changes in the ocean current, melting of the ice that's on land, those sorts of things. The release of methane gas, okay, with the permafrost. So I would say that 100 trillion over 100 years should be weighted initially towards doing floating mirror fields to quickly reverse the effect as we bring up all of the clean energy systems that are out there.
Tom, thank you so much for giving us this presentation. And it's really been a lot of action also among our audiences. So I thought I would maybe address some of the questions as we do have some time. And also, of course, Bob, if you find any questions that have been answered yet. Is that okay, Tom, that I address some questions from the audience?
Yes, that's perfect.
I have one here from Liliane. She said, would like to hear about how marine life, plankton, heat, and so forth in the ocean that is needed to preserve life, how this is affected by this solution,
Well,
by the mirror.
yeah. Well, the mirror fields keep moving so that we don't create a stagnant place. They move about 10 miles a day chasing the sun. They're way above the water level. So even great big whales that are leaping out of the ocean would not notice it. So we think that those two facts, that we're high above and we're constantly moving slowly, would stop us from causing damage in one particular place. You know, I grew up on the great, in North Queensland, Australia, by the Great Barrier Reef. And my mother was a biologist, and we would go out to the reef. So I'm very, very cognizant of the marine environment, having grown up in such a place with such a mother.
Another way to look at this is the phytoplankton that generates so much of our oxygen are also attacked even today by the acidification of the ocean due to the increase in heat that it's absorbing. So this would reduce the amount of heat absorbed and acidification of the ocean. And I would say it's probably overbalances, if you will, the effect of anything that could possibly happen due to the mirror fields.
One of the things that we have going for us is that there are often unintended consequences. And sometimes things are put in that can't be easily reversed. But floating mirror fields, the mirrors can be very quickly wound up. In other words, the whole thing could be reversed, nullified, taken away in one day. If something was serious that came up, there was an unintended consequence. So we've been thinking about it. And I don't think we can't see any big marine negative consequences.
And I also think another, which was also a question that I had, bearing in mind your solution, how has it been received? I mean, where it can actually, whether it's has the UN addressed it and seen it as a solution, how do you go about to actually make this solution accessible and to get funding for it?
Well, we present to places like Humanity Rising so that people are aware of it. And I'm hoping that people listening will start to talk about these solutions and be encouraged that there is a way forward. But the National Science Foundation, I was very delighted, last week wrote to me and invited me to put in a submission for quite a lot of money to do some of the initial basic research that's necessary to put together a thing like this. And that would pay for the modeling, etc. There'd be a whole team of people involved. And at that stage, we could then start looking for some of the big money. But I think that the big money is actually going to come from very wealthy individuals. I think that the Middle East emirs and rulers are going to be important players. And we've already seen Mubadala step up and invest some money in the program.
And we also had a suggestion here from Wesley in the chat, who just wanted to convey that Project Drawdown exists. And he said, have you contacted them? Because maybe they could consider the heat pump and floating mirrors as a solution. So just as a suggestion.
No, we haven't reached out to them yet, but yes, you know, we will be starting to reach out to all these people. The thing about it is the time is right. I mean, exactly. It's amazing how anxious the world is. Well, it's not amazing. It's what it should be, the situation, that people are looking for solutions. So, you know, throwing one solution out that very quickly can produce results, and that's the floating mirror field, as other clean energy systems, including our ocean heat pumps, start to come in. We think that's one of the big positives, is that there's a quick impact.
Bob, do you have any more questions or thoughts?
Just a thought, reflection that it is through sort of conversations, grassroots organizations, the Greta Thunbergs of the world that start gathering attention to these topics. And, you know, one person, 10 people cannot really do it. It's the, you know, multitudes that speak about it, talk about it, raise awareness of it, that really cause actions that are sustained.
That is so true. And that's why I think it's so important. And it's also dialogue that has been in the chat, that individuals and grassroots organizations, but also, Tom, you mentioned a consortium of different actors coming together, and the World Carbon Tax. I mean, there are so many initiatives that are solutions in addition to the innovations that are coming. And it's probably bringing a lot of stakeholders to the table from all the different perspectives, and going from raising awareness to really taking action. And that scientists and pioneers and innovators like yourselves, both of you, are sort of part of that dialogue. That's also so important. But we at Humanity Rising are so thrilled and also honored to be able to make this a platform for people who both have the knowledge, the expertise, and the innovations and the solutions, because that's where we need to put the highlight. The problems we already have, and they're well highlighted all over the world, but it's also shifting the mindset of each individual to know that we can take responsibility and also act as a solution, because sometimes it can become so overwhelming with all the climate change.
Yes, you know, there was an article recently in Foreign Affairs that was written by a person who was very scornful of people trying to come up with solutions. His comment was, it's too late, stop being idiots, okay? Resign yourself to a future that's flooded, that's hot, that has violent weather, that has millions of people, you know, looking for a place to live. And I thought that attitude, giving up and resigning yourself to the terrible consequences that are coming, saying that there was no path, when I can see a path myself, and other people see paths, I think what's important is that people don't get so discouraged that they give up, that they get out there and they push and they push and they push, and basically, yes, we can do it. Because I think there are paths, if people download my presentation, you'll see that there are 2 extra pages that list off, okay, key criteria to judge these things by, so people can think more about it. But it's too comprehensive to present to a presentation like this. So I guess
Jim,
I guess that was my big goal, was to show people that there's a path, and there's probably quite a few paths, and we've got to keep going and agitating and pushing hard, okay, to get the people that control the money to start investing.
Very good point. And Jim, I see you're on board here now. Do you have any reflections or perspectives on this to share?
Yes, I first want to thank you, Tom and Bob, for your extraordinary command of the information and the engineering technicalities and the ideas. I think the only comment that I would make is twofold. One, you know, the law of unintended consequences. is probably the most relentlessly present law governing human history and natural systems. And I think if I have a concern about your proposal, it's the law of unintended consequences, something that might seem very simple from an engineering point of view. We have a pretty bad track record as a human race with ideas that seem superficially attractive, but once they're implemented, they unleash consequences that were never imagined. And I just want to say that as I listened to your presentation, I had growing concerns about the law of unintended consequences. The other side of this is that it feels to me that there's a much simpler, cheaper way. If humanity would react to climate change like we just reacted to the pandemic, and we focused on implementing donut economics around the world, we focused on regenerative ecological projects at massive levels to replant the trees, to repopulate the ecologically devastated systems. I think the unintended consequence we would find there is that nature has an extraordinary capacity to rejuvenate itself. So I think this is worth, we're out of time now, but I would really challenge all of us to think carefully about massive, technologically complex and massively expensive systems, the consequences of which we know almost nothing, when the most obvious solutions, which is really to reorient humanity's relationship to nature itself, feels to me to be the most organic, much less expensive, and with consequences that would be rejuvenative rather than unimaginable. So I just want to put that out there, Tom and Bob. I think there's two sides of the coin here that we need to contemplate.
Jim, could I sort of comment? The unintended consequences has been a worry for us all along, and the whole idea of having something that can be quickly reversed by winding up the mirrors. Okay, if some unintended consequence becomes apparent, I agree 100% with you. Where the hell are they coming from, and what are they going to be? But I think at the bottom of things, for all of us to start behaving appropriately and minimizing the damage that we personally do to the environment, leaves aside the overwhelming fact that the big problem is 1 trillion tons of carbon dioxide in the atmosphere. And we can behave wonderfully well, okay, and do all the things that those of us who are human-oriented think about. But in the big scheme of things, it's irrelevant. What's killing us is the big carbon dioxide.
Completely agree with that. I mean, that's why the gentleman in foreign affairs, really has a point. Is it already too late? Have we passed the point of no return? That is something that, as you know, Tom, as a scientist and an engineer, more and more people, more and more scientists are beginning to conclude. And so that's why the scientists around the world are begging humanity, begging our governments to take climate change far more seriously than the pandemic. The pandemic is just a little pimple on the back of the buffalo. The buffalo is climate change. And that's why I was accentuating, I believe this is the first time that a governor of California was courageous enough to say that the forest fires are due to climate change. And Governor Inslee in Washington State, to my knowledge, it's the first time, on national TV, these guys are beginning to state what the actual truth is that's obvious to anybody who's paying attention. And you're right, there's this lag while the trillion plus particles and global warming and deforestation, et cetera, are taking place. We got a long way to go to catch up to where we need to be to make the decisions, even to support your solution.
Yeah.
Because the world is in deep denial about the most obvious fact in the world.
Yeah,
It's
Bob,
an extraordinary state of affairs.
Bob, you and I have talked about this before, and I observed to you that the fundamental problem is a physical one, which is all of this carbon dioxide in the atmosphere. And the fundamental response is going to be a physical one too. I mean, we can do all the things with human dynamics and being good people, et cetera, but carbon dioxide doesn't give a damn, okay, about us, okay? It's just blocking the heat getting out. And that's the fundamental problem. We have to, at some point, all of this good vibes that we have with each other and people and good behavior, it's not going to do it if it's not a physical solution to the physical problem.
Yeah, just one comment I'd like to make as well. I agree with both sides of this conversation in that the solution is in the hands of those who care. But if those who care are not a large enough percentage of the population on the planet and are not in position to be able to do things like much of the poorer nations of the world, then that will not be enough. So I think it's a partnership between the human efforts and the scientific efforts that will help us the most. To rely on one or the other is really the wrong path.
Yeah. Well, I'm afraid we'll have to bring it to a close there. Sabina, did you want to say anything, or should I just close us out since I'm already have the floor, as it were? What's your pleasure?
Please do, Jim.
Okay. Well, Tom, thank you. Bob, thank you so much. This has been splendid. I always feel blessed when I'm in the presence of great minds whose hearts are dedicated to the common good. And I think everyone, we've seen that with Tom Hopkins. I mean, here's this guy, brilliant engineer, and he's dedicating his intellectual, creative capacities to trying to save the world. So Tom, I just want to acknowledge that and thank you for your service to humanity. And Bob, thank you for joining in. This has been a very profound session. And among other things, it shows us the extremis of our situation. Tom is only coming up with these kinds of solutions because our situation is so extreme. And sometimes when you have an extreme situation, you got to use extreme measures. I mean, sometimes when you have an infection on the leg, you got to cut the leg, and you got to risk those unintended consequences to save the body. And we're getting to just about that place with climate change, and we should all take it in. So thank you, Tom. Thank you, Bob.
My pleasure.
And then tomorrow, we're going to turn to another quite extraordinary subject, going, from the sublime to the more sublime. And we're going to have a dialogue between Peter Mary, the Chief Innovation Officer for Ubiquity University, and Brenda Dunn. You may remember must have been 20, 25 years ago. Brenda Dunn and her husband conducted some experiments in Princeton, demonstrating that human beings have the capacity to communicate through non-locality. And you know, the physics experiments where you change an electron and the electron way, way away is simultaneously changed. That the perturbation anywhere in the universe is felt by everything in the universe, because the universe is not only completely interconnected, the universe is sharing information instantly, all the time, about everything. We're being impacted, and everything we do goes into the grand pleroma of life as a learning system and continual feedback loop. And that's one reason why human beings can engage in mental telepathy. One person in China can communicate through mental telepathy with someone in the United States, communicating with no locality, no proximate locality. The whole phenomenon of psychic insight and prescience is based on the notion that the universe is one. You can create an intention and create an effect over distance. So anyway, as we think about what we need to do in the extreme situation in which humanity finds itself, one of the things is to come to terms with the fact that we are more than just iPhones. We are more than just consumers. We are beings with immense psychic powers. If humanity would come together as one with a single clear intention, we could deal with climate change in a nanosecond. That's a fact. And that may seem like the most unimaginable thing in the world. But when you listen to the session tomorrow between Peter and Brenda on humans communicating through non-locality, and you really come into an awareness of how potentiated we are as sentient beings on this planet, you become aware that we're using only a fraction of our potential each and every day. And it's time that humanity upgrade to deal with the complexity of the challenges that we face. So we're going to go from climate change to the Princeton experiments on human potential tomorrow, starting at 5 o'clock to 6:30 Central European time. I'll see you all there. Thank you, everyone. Tom, Bob, Sabinia, thank you all. We'll see you tomorrow. Bye-bye.